This is the Matrix keyboard I designed for my e-ink phone project. In this video, I'm going to explain how it works, why I decided to build my own PCB instead of buying one off the internet, and all the issues I encountered. So let's just start with the final product, how it looks. Right here is 4 pins. In afterthought, after I ordered the PCB, it's too late now, I noticed I forgot to add power, which is a pretty important thing. So it's not going to be a big issue. There's power on plenty of power pins I can interface to on the chip, and this decoupling capacitor right over here, if I can move it. This decoupling capacitor, I can always inject power there. So not a big issue, but don't forget to add power to your circuit boards. That's my pro tip of the day. Anyways, these are the 4 pins that we need. In a second, I will go explain what they're for. On the front, we have the slots or the spots that we can put all the surface mount switches. So we have the normal QWERTY layout. It's a bit weird with the special keys. This is backspace, and this is enter, but it shouldn't be too bad. I added room for a through-hole LED, as well as this surface mount LED. The goal is just, in the end, I'm going to probably use surface mount, but as I don't have any with me right now, I'm just going to do testing with a normal one. We also just added space for a resistor, plenty of resistors laying around, that should be fine. The only other major thing on the front is just going to be these screw holes that go through the board. On the back, you can see all the diodes, which I expect to be a pain to solder. Hopefully it all fits and works, but it's going to be a pain. And then this is the I/O expander that uses I2C, and then this is just a decoupling capacitor. Okay, let's go through the schematic and explain how a Matrix keyboard works. So the main reason we're using this I/O expander is because if you've seen the last video, you see I don't have that much GPIO left. It might look like I do, but the modem hat takes 5 or 6, and the screen takes around 5 or 6 also. And the ones left, a lot of them are ground, and not a lot are actual usable GPIO pins. So the main reason is because I don't have room for, what is this, another 10 or 16 connectors. I cannot connect that to the Raspberry Pi. So what we're going to do is use I2C to change from all these 16, I believe, 16 connectors. We're going to just make that into 2 I2C pins. So over here, this is that header I was talking about earlier. We can see that we have the 2 I2C pins connected right there, and then we also connected interrupt A and interrupt B, which we'll get into later, but basically you can use it to have the chip send something to the computer when something changes. So VDD is positive 3.3 volts, I believe. I might run it off of a higher voltage if I can, because we might need it for these LEDs, but we'll get into that later. There's a few issues, but this was not the main part of it. VDD is positive, so we have that connected nowhere. As I said, I forgot to add power, most important thing, but it's a surface mount chip. I'm soldering it by hand in the first place. I should easily be able to connect something there. VSS is ground, and you can see here we have a decoupling capacitor, which we have a hole for in the board. And then we have this connected to ground, which again, I forgot to connect, but we'll just connect up here. The one issue that I realized also too late is that I'm not sure if this chip can handle the power to drive an LED, and I'm also not sure if the voltage will be high enough. Again, the LED was kind of an afterthought. I thought I have an extra pin, we might as well use it. So this is not a super important thing, but we could always jank it and make it work. So this is the biggest part of the schematic, the matrix layout. I'm going to just show you guys over here how one of these works. So basically, this is an oversimplification, and I'm probably going to be pulling stuff low instead of high. But I have not actually built this yet. I just read enough about it to make the design, and the rest I'm figuring out later. So basically, this says if we put power to this column, we're going to pull through them all. So if we start here, and then we just go like this. When power is on this one, if we press this switch, the power will also go through this diode and then light up this one. So then we can see when we give power to this, and then we see power coming out on this, that means we must have pressed this key. The reason we have the diode is because we don't want stuff happening like if we are powering this, right, and pressing this switch, and the power goes out here, we do not want it to go back up here and then activate any of this. Because then if you're pressing this switch at the same time, as I believe there's a good example, if you're pressing other switches at the same time, it could confuse the code in the microprocessor. So that's basically how a matrix layout works. I'll put this website in the description. It helped explain it a lot, had some decent photos, and yeah. So back to the schematic. These, it's hard to see with this many wires, 22 and up. So all these are going to be the columns. Columns? Yes, the columns. So that's this voltage right here. When we pull through it, we'll pull it high or low, again, not decided yet, and then we'll read through all this. So, these ones right here are the rows. We have 1, 2, 3, 4, 5 rows, which is for these 5. And then we see, if there's a voltage here, we can triangulate the key that you're pressing. So now that I've explained the basics of this circuit, I'll have the data sheet and everything from DigiKey in the descriptions also. If you want to copy it, you can. We're going to go into the PCB editor. So, you may wonder why everything is so squished. The main thing is I did not want this phone to be super wide. The issue was only e-ink screens I could find were either 2 inches or 4 inches, which kind of makes it annoying. I ended up getting the 4-inch screen, and so that's diagonal, so 4 inches diagonal is about 80 millimeters wide, I believe. That's what I was basing this off of, and I believe I got this keyboard to 69 millimeters, so it's just small enough so that it's smaller than the screen and we can fit the rest of the 3D printed in. But to check, we can just go measure, and then we connect there, and then connect the other end to the end. 69 millimeters, there we go. So that is why it's very compact, and I was trying to keep everything spaced as closely as possible here. That's also why the keyboard layout is really weird. You can see right here we have the chip, which is on the back, and then we have this decoupling capacitor. The rest of the wiring is a bit crazy, but basically we have, in this case I actually send the power to the rows from the bottom. It does not really matter, but it's just how it ended up working in the PCB, because we do want the top of the keyboard to be pretty close to the screen, so it feels a bit more natural. So we have all the keys wired, and then I just wired these LEDs up so that you can power them from one of these pins, and that's basically all of it. It just took a long time to wire up every individual key. So that's how everything works in here, and I'm just going to show you the parts and switches I ordered, and we're going to hope that they are easy to hand solder, otherwise I'm going to have to buy surface mount parts to add it. So here, if we go to DigiKey, I ordered a bunch of diodes. Okay, I ordered the wrong diodes. This is fun. I ordered through-hole diodes, which was my original idea, and I ended up switching to not through-hole diodes. So I guess we're gonna make a new DigiKey order. I'll be right back. Okay, sorry for that. I mistakenly, on the original order, I somehow ordered through-hole diodes when I switched the design to surface mount. I somehow didn't notice that in my order. Don't know how that happened. So, we just placed a new order. Now I'm gonna go through the pieces and parts I selected, and hopefully I do not find anything that was wrong, because that would be really bad because I have to pay more shipping. So we're gonna start with the original order. Ignore this. This is useless. I guess I have a bunch of tiny, cheap diodes now. These are the I/O expanders. I got 4 of them. They're kind of pricey, but it's fine. If we just open this, this is the I/O expander we're using. It has 16 pins that it expands to, and it's over I2C. So this is just gonna get hand soldered, not a horrible price, and yeah, it seems like it should work fine. I'm again not sure if it will work with the LEDs on the board, but that was kind of a last minute why not add it. We have an extra pin thing, and I can always use the pin for something else. I just don't wire the LEDs, so it'll be fine. The next thing in this order that is correct is the switches. So, sorry, open this in a new tab. The switches, I used this long monstrosity of a name. They look very tiny. That's because they are tiny. I'm hoping that it will be okay, an okay feel to type on, but I'm not sure yet, but I might 3D print like an actual keyboard that goes on top of it and just pushes these buttons. I'm not really sure what way I'm going to do it, but we're just going to see how it feels once I put it together and how it looks. So these guys are pretty tiny, and that's on purpose, because I have to fit this whole circuit board in 75mm of space, which is not that much. It's about the size of a keyboard on your phone. So those are the switches we ordered. And then if we go to the new order, where I fixed the diodes, I wrote a few other things also. These are the new diodes. It's what I was supposed to get in the first place. SOD323 is the PCB footprint that we need. It all looks good. Hopefully these are correct. And this is what we're going to be soldering. And then, in the new order, I also decided to get, with the several loads, I decided to get some small 1.5 watt amplifiers and some small, a single small 1 watt speaker, because I might want to add it to the thing, and I'm paying $6 shipping, so I better get my money's worth. So that is the PCB that I designed. Speaking through this, I definitely have noticed some flaws. I was definitely rushing to get it in before we went on vacation, so it would get here sooner. But I think it came out pretty well. The most important part seems to be fine, the switches. The diodes, I ordered the wrong ones, but as we see, it should end up being fine. And I'm gonna have to find a capacitor, but I have capacitors. I'll be able to find them, no problem. The only thing is I'm not going to be actually putting a header here. This is just going to be wires, because I do not have room for huge headers like that in the final design. But yeah, this is the final keyboard, and I'll make a new video once I get the PCB, and probably film myself putting these things together, which take forever to put together. So thank you for watching this video, and please like and subscribe.